Okay, so let's continue on. Let's see, I did that one. Right, example. Find the center of mass of a thin plate of constant density delta covering a region, the region bounded by the x-axis and the curve y equals 3 cosine x negative pi over 5 is less than or equal to x is less than or equal to pi over 5. Okay, so they gave us an interval, so we don't have to find our interval. So our center mass, or what we think it's going to be, tilde x, tilde y, is, now, when we draw this picture, okay, we go from negative pi over 5 to pi over 5. This is up to 3. Oops, not good. This is symmetrical at the y-axis. F of x, which is 3 cosine x minus 0. So it's x, comma, 3/2 cosine x. Our length is equal to 3 cosine x minus 0, which is 3 cosine x. Our width is dx. Our area is 3 cosine x dx. dm equals 3 delta cosine x dx. Now, let's go ahead and find m. M is the integral dm from a to b of dm. So that's the integral from negative pi over 5 to pi over 5, 3 delta cosine dx. So that's 3 delta integral from negative pi over 5 to pi over 5 cosine x dx. Now the inverse of cosine, or the integral of cosine, is sine. So this is 3 delta, oops, looks more like an 8. Delta sine x negative pi over 5 to pi over 5. So that's 3 delta sine of pi over 5 minus sine of negative pi over 5. Now remember that sine of negative theta, that is not a theta. theta equals negative sine theta. So this is 3 delta sine pi over 5 plus sine pi over 5. So there's 2 of these. 2 sine pi over 5 times 3 delta. So that's 6 delta sine pi over 5. Now that's our denominators. Now, since the graph is symmetrical, about the y-axis, x bar is 0. So what we need to find is mx, which is the integral from a to b, delta over 2 f squared x minus g squared x dx. So that's the integral from negative pi over 5 to pi over 5, delta over 2 times 3 cosine x squared minus 0 squared dx. So that is delta over 2, negative pi over 5 to pi over 5, 9 cosine squared x dx. So this is 9 delta over 2 integral from negative pi over 5 to pi over 5. Now remember that cosine squared x can be written as 1/2 1 plus cosine 2x. Okay, so that's going to be 1/2 times 1 plus cosine 2x dx. So that's going to be the integral of 9 delta over 4, because we're going to put this 2 and this 2 together. Integral from negative pi over 5 to pi over 5 of 1 dx, plus the integral from negative pi over 5 to pi over 5 of cosine 2x dx. We're going to let u equal 2x and du equals 2 dx. Going to divide by 2. So this is 9 delta over 4 times the integral from negative pi over 5 to pi over 5 of 1 dx, plus 1/2, well, plus the integral from negative pi over 5 to pi over 5 cosine u du over 2. So I'm going to bring the 1/2 out front, and I've got 9 delta over 4 times x from negative pi over 5 to pi over 5 plus 1/2 sine u from negative pi over 5 to pi over 5. So that's 9 delta over 4 times x to the pi over 5 to negative pi over 5 plus 1/2 sine 2x from negative pi over 5 to pi over 5. Okay, so that's going to be 9 delta 4 that's going to be pi over 5 minus negative pi over 5 plus 1/2 sine 2 pi over 5 minus 1/2 sine 2 times negative pi over 5. So that's 9 delta over 4 times pi over 5 plus pi over 5 plus 1/2 sine 2 pi over 5. Now remember, that minus can come out and make that a plus. 1/2 sine 2 pi over 5. So that's 9 delta over 4 of 2 pi over 5 plus sine of 2 pi over 5. Because these two halves make a whole. Okay. So now y bar is mx over m. So that's going to be 9 over 4 delta times 2 pi over 5 plus sine 2 pi over 5 over 6 delta sine pi over 5. The deltas cancel, and we get 0, comma 9/4 times 2 pi over 5 plus 5 sine 2 pi over 5 divided by 6 sine pi over 5. And that's the exact answer. Okay. Example. Find the center of mass of a thin plate of constant density delta covering the region in the first and fourth quadrant enclosed by y equals 2 over 1 plus x squared and y equals negative 2 over 1 plus x squared, and by the lines x equals 0 and x equals 1. So if I draw that picture, 2. Okay. So here, here, it goes 2. Okay, so there's my picture. And we're looking at this region here. We're going to draw, there's one of our strips. Okay, so overall, center mass we predict to be 0, 0. Our length is equal to f of x minus g of x. This one's the f of x, and this one's the g of x. So 2 over 1 plus x squared minus negative 2 over 1 plus x squared makes 4 over 1 plus x squared. Our width equals dx. Our area equals 4 over 1 plus x squared dx. Our dm equals delta 4 over 1 plus x squared dx. Now they told us from 0 to 1. So m equals the integral from 0 to 1 of delta 4 over 1 plus x squared dx. So that's 4 delta integral from 0 to 1 over 1 plus x squared dx. So that's 4 delta tangent inverse x from 0 to 1. That's 4 delta tangent inverse of 1 minus tangent inverse of 0. That's 4 delta pi over 4 minus 0. So that would be pi delta. Now, since symmetrical about y-axis, y bar equals 0. Not symmetrical about x on 0 to 1. So find x bar. So to find x bar, we need my. My equals the integral from a to b of x delta times f of x minus g of x dx. So my equals delta times 0 to 1, or from integrate from 0 to 1 of x times 4 over 1 plus x squared dx. All right, we're going to let u equal 1 plus x squared, and du equals 2x dx. Now, I have the x and the dx right there. And then this 4 can be split into 2 times 2. So there's one of my 2's. Okay. So I've got this 2, I'm going to bring out 2 delta integral 0 to 1 x 2 over 1 plus x squared dx. Okay? And so now that's going to be 2 delta integral 0 to 1 of 1 over u du. Because see, now you can see I got my dx, I got my x, I got my 2, and I have my 1 plus x squared. Everything's taken care of. So that's 2 delta ln of u from 0 to 1. Okay, so that's 2 delta ln of 1 plus x squared. Now we could put parentheses because the x squared is positive no matter what we plug in, but we're plugging in 0 to 1, which are positive numbers. So that gives me 2 delta ln of 1 plus 1 squared minus ln of 0. Okay, so that's 2 delta ln of 2 minus 0. Oops. Correct that. 1 plus 0 squared. So that's going to be ln of 1. So that's 2 delta ln of 2 minus 0, which is 2 delta ln of 2. Now we're going to set that up to do x bar. X bar equals 2 delta ln 2 over pi delta. The deltas cancel. That gives me 2 ln 2 over pi. Okay, and so that would be 2 ln of 2 over pi comma 0, or I can pop that 2 up there and make it ln 4 over pi comma 0. Okay. All right, example. Find the center of mass of a thin plate of covering the region between the x-axis and the curve y equals 2 over x squared, comma 2 is less than or equal to x is less than or equal to 4 if the plate's density at the point xy is delta x equals x squared. Yep. So x, y, 2, 3, 4, 1/2, 2/9, 1/8. 1, 2, 3, 1/2, 2/9, 1/8. Okay. So center mass should be x, half of the function, half of 2 over x squared. So that's x, comma, 1 over x squared. Length is 2 over x squared. Width is dx. Area is 2 over x squared dx. dm equals delta area. So that is x squared times 2 over x squared dx. The x squares cancel, and I get 2 dx. Okay, now there's no symmetry here, so we're going to have to find both the x and the y. Okay, m equals the integral from a to b of dm, which is the integral from 2 to 4 of 2 dx. So that's the integral from, well, that's not, we integrate, sorry. So that's going to be 2x from 2 to 4. That's 2 times 4 minus 2 times 2. 8 minus 4 is 4. That's m. Okay. Now, my equals the integral from a to b of x delta f of x minus g of x dx. So that's the integral from 2 to 4 of x times x squared times 2 over x squared dx. The x squares cancel. I've got 2 integral 2 to 4 of x dx. That's 2 times x squared over 2 from 2 to 4. The 2's cancel. That gives me x squared from 4 to 2. So that's 4 squared minus 2 squared. That's 16 minus 4, which is 12. mx equals the integral from a to b of delta over 2 f squared x minus g squared x dx. So that's going to be the integral from 2 to 4, 1/2 x squared, that's delta x, times 2 over x squared squared minus 0 dx. So that's 1/2 integral 2 to 4 x squared times 4 over x to the 4th dx. That's 4 over 2, integral 2 to 4 of 1 over x squared dx. So that's 2 integral 2 to 4 of x to the negative 2 dx. 2 times x to the negative 1 over negative 1 from 2 to 4. That's negative 2 times 1 over x from 2 to 4. That's negative 2 times 1 over 4 minus 1 over 2. Oops, sorry. That's negative 2 times negative 1/4, which is positive 1/2. So now x bar equals 12 over 4. So x bar equals 3. Y bar equals 1/2 over 12, over 4, excuse me. So that equals, y bar equals 1/8. So my answer is 3 comma 1/8. Okay. Example. The region bounded by the curve y equals plus or minus 3 over the square root of x, and the lines x equals 1 and x equals 4 is revolved around the y-axis to generate a solid A. Find the volume of the solid B. Find the center of mass of a thin plate covering the region if the plate's density at the point x comma y is delta of x equals 1 over x. C. Sketch the plate and show the center of mass. Your sketch. Okay, so Okay, x I that's the positive. This is the negative. All right, so 1, 2, 3, 4, 3, negative 3, 3 over the square root of 2, negative 3 over the square root of 2, 3 over the square root of 3, negative 3 over the square root of 3, 3 over 2, negative 3 over 2. So at 1 we get 3. 4 we get negative 1 and a half. At 4 we get to 1 and a half. 1 and a half. Negative 3, 1 and a half. Okay, so for A, volume equals the integral from A to B, 2 pi times the shell radius times the shell height dx. So the height is equal to 3 over the square root of x minus negative 3 over the square root of x, which is 6 over the square root of x. So v equals the integral from 2 to 4. No, 1 to 4. 1 to 4 of 2 pi x times 6 square root of x dx. So v equals 12 pi integral 1 to 4 x times x to the negative 1/2 dx. And the square root in the bottom. And so v equals 12 pi times the integral from 1 to 4. 1 minus a half is a half dx. So that's 12 pi, and that's x to the 1/2 plus 1 over 3/2 from 1 to 4. So 12 times 2 over 3 pi, x to the 3/2 from 1 to 4. 3 goes into 12 4 times. So we have 8 pi times 4 to the 3/2 minus 1 to the 3/2. Okay, so that's 8 pi. And that's going to be, you do 4 to the 3/2, 4 squared is 16, the cube root, no. 4 cubed is 64. 4 cubed is 64, the square root of 64 is 8. 1 cubed is 1, square root of 1 is 1. So that's 8 pi times 7. That's 56 pi cubic units. Okay. And why did I pick the shell? I could use the disc or the shell method. Not the washer because there wasn't a hole in it. Part B, CM is X bar, Y bar. right, symmetrical. About the x-axis and density. Symmetrical. About x-axis. So y bar equals 0. All right. Length equals 3 over the square root of x minus negative 3 over the square root of x, which is 6 over the square root of x. Width is dx. Area is 6 over the square root of x dx. dm equals delta times the area, which is 1 over x times 6 over the square root of x dx. Okay. M equals the integral from 1 to 4 of 1 over x times 6 square root of x dx. So that's going to be 6 times the integral of 1 over 4, 1 to 4, x to the negative 1, x to the negative 1/2 dx. So that's 6 integral from 1 to 4, x to the negative 3/2 dx. So that's 6 times x to the negative 3/2 plus 1 over negative 1/2 from 1 to 4. So that's going to be negative 12 x to the negative 1/2, 1 to 4. That's negative 12 times 1 over the square root of 4 minus 1 over 1, square root of 1. That's going to be negative 12 times 1/2 minus 1. That's negative 12 times negative 1/2, which is 6. Okay, so now my equals the integral from a to b x delta times f of x minus g of x dx. That's the integral from 1 to 4 x times 1 over x times 6 over the square root of x dx. This x cancels with this, and that gives me 6 integral 1 over 4 x to the negative 1/2 dx. So that's going to be 6 times x to the negative 1/2 plus 1 over 1/2 from 1 to 4. That's going to be 12 times x to the 1/2 of 1 to 4. That's 12 times the square root of 4 minus the square root of 1. That's 12 times 2 minus 1, which is 12. My equals 12. M equals 6. So x bar equals my over m, which is 12 over 6, which is 2. So 2 comma 0. All right, there you go.